Hello and welcome to the AWS Innovate Online Conference. Today's session is going to discuss protecting your data assets with AWS with a particular focus on backup and recovery. My name is Luke Anderson and I'm part of the Storage Business Development team. I'd like to start with an overview of the storage services we have available in AWS. As you can see, we have block, file and object store offerings in the center of the screen. For block storage, there's Amazon Elastic Block Store, which I'll refer to as EBS for the remainder of this presentation. That provides block storage for EC2 instances running inside of AWS. For file storage, we have Amazon Elastic File System, which I'll refer to as EFS for the remainder of this presentation. EFS is our NFS-based scalable file system that provides file services via NFS to workloads that are running inside of AWS. And with one of our recent releases, we provide the capability to connect your own data center file systems to EFS. And then at the bottom of the circle, we have Amazon S3 and Amazon Glacier that are referred to as S3 and Glacier for the remainder of this presentation. S3 and Glacier are AWS's object storage offerings that are foundational to moving workloads into AWS, including large data sets and used in building things like data lakes and compliance archives. On the right-hand side, you see AWS's data and security management services, ranging from data discovery and protection provided through Amazon Macie service, through to data visualization service with AWS QuickSight, through to AWS CloudTrail and identity access management capabilities with AWS IAM and AWS KMS providing encryption. Today's focus will be on AWS Storage Gateway, storage partners, and AWS Snow services. Let's just quickly describe the difference between backup and archive. Now, backup is your traditional, I want to make a copy of my data, where the outcome of a backup is to have an authoritative copy that can be restored to certain applications or data sets to a point in time. Now, typically these backups are kept somewhere safe, either on-premise disk, tape, or in many instances transferred to off-site data bunkers for additional retention and storage. Now, the term archive is the movement of this authoritative copy to somewhere safe. Now, it doesn't necessarily need to be readily and hot accessible for instant access. It just needs to be preserved safe and be able to be restored back when and as needed. So in summary, a backup represents an authoritative point-in-time copy of the data, and an archive is the only copy of the data. Why choose AWS for backups? Some of the business and technical drivers for our customers moving their backup workloads to AWS are cost effectiveness. With pay-as-you-go pricing model and no upfront capital investment, this differs from the traditional model today, which requires organizations to procure 12, 24, or even 36 months of infrastructure upfront. The second one is elimination of infrastructure and administrational overheads. The traditional approach to running backups involves large data centers and operational teams to perform backup maintenance activities, everything from maintaining and moving the disks and taking the tapes out of the silos into offsite storage. As you move your backup jobs to the cloud, you start getting the benefit of automation. You can utilize existing backup applications that you have deployed today and then start automating the whole back-end workflow through a preset schedule. Finally, by backing up the data to AWS, you now have the ability to apply analytics, artificial intelligence, and machine learning to the data sets. From speaking with our customers, we are seeing a number of trends emerging in the market. One of the first trends is around auditability, especially along the lines of GDPR or General Data Protection Regulation. Our customers are being audited and expected to provide detailed logs and information about where, what, and how their end customer data is being stored. With AWS CloudTrail, AWS CloudWatch, and object tagging on S3 objects, we are helping our customers to meet their audit requirements. We see this trend increasing over the coming months as protection, governance, and control of our customers' data assets increases. Ultimately, the aim will be to treat your customer data as a protected, scarce asset that has intrinsic value. The next one is protection against ransomware. As we've seen over the last few years, the number of organizations being attacked or at risk from ransomware is increasing. A way that some customers are mitigating against this risk is to have their backups or another copy of the data stored immutably in the cloud. Using Glacier Vault Lock capabilities, we can provide copies of that data in immutable storage and in essence creates what we're referring to as an air gap between on-premise environments and what's in the cloud. So if our customers ever do become at risk or susceptible to a ransomware attack, they have a clean, fresh copy on AWS that they can restore from, or even build a DR replica of their applications within AWS in a short space of time. Finally, in some examples, we are seeing our customers remove their expensive, dedicated connections to replace with lower cost transit and multiple routes. This is for some customers that are more interested in the size rather than the SLA. Now let's cover the traditional backup and restore workflow before the cloud. This is the workflow that I have used when I was a systems administrator and is still in operation today at many organizations. On the left, we have the application server. The application servers are the consumers and creators of the information and data that you need to preserve, backup, and protect. To do that, you often have a media server sitting on premise that is aware of your applications, either through network discovery or through agents deployed on them. The media server has control of what the backup policies are, what the backup jobs are, and what their retention period is. You then make authoritative copies of the application service information and data to either local disk for immediate restoration or to on-premise tape storage for archive. In some instances, additional redundancy of the data, organizations will transport either their primary copy or secondary copy of that data to an off-site data bunker. Now, there are inherent challenges with this existing process in terms of lifecycle management of existing infrastructure, including the media server, tape storage, and physical tapes themselves, such as LTO or linear tape open. As the tape hardware evolves, older tape versions become end of support. That requires lifecycle management to transport the data from the older version to the latest. All of this takes time and resources to perform, not to mention the additional hardware investment for new tape drives. Now, there are two mechanisms that we have to deploy and to help you move your backup to AWS. The first is called Cloud Connectors. Now, Cloud Connectors, you will notice, starts with exactly the same workflow where you have your application server on the left. Now, in this instance, the media server, rather than writing over iSCSI to an on-premise tape silo or disk drive, the media servers now have an HTTPS or internet connection to AWS. The Cloud Connectors can write natively to Amazon S3, SIA, or Glacier. The type or tier of storage depends on your workforce needs. S3 standard for workloads that require a hot access to their backups for immediate restoration. For longer-term archive data or data that would be typically couriered to an off-site data bunker, our customers can move the backup sets to Glacier. All of this movement can be performed and automated via lifecycle management that moves the data through the tiers. For example, you could create a lifecycle policy for all of your monthly backups that are over 90 days old and move them to Glacier for long-term archive. There are a growing number of organizations listed on this slide. Each one of these has already built in native connectivity to Amazon S3 or Amazon Glacier, either through the API, SDK, or command line interface. Even if there is only an S3 integration, you can still move copies to SIA or Glacier using lifecycle policies. Now, if you're currently operating with one of these organizations performing backup jobs and you're looking at getting into the cloud, I suggest you get in contact with them to start the journey. Now, the second connectivity is via gateway technology. So if you have an existing backup application deployed in your environment today and you have no plans to upgrade it to a newer version that has the AWS interface, we can deploy gateway technology, either AWS or a partner solution. In the AWS example, the gateway is deployed via a VM within your environment that mimics the same interface as you'd have for tape or a disk to enable you to write the data to AWS either via the internet or through AWS Direct Connect. There you can see on the right-hand side that we have Amazon S3, S3 and frequent access, and Glacier endpoints, and now support Amazon EBS snapshots with the volume gateway that we'll cover later. The AWS Snow service is made up of the AWS Snowball, Snowball Edge, and the Snowmobile. With the AWS Snowball, you get 80 terabytes of capacity, 10 gigabit network connection, and when you copy data and write data into the Snowball and the AWS Snowball Edge, all of that data is going to be compressed and encrypted. An important thing to note is that the encryption key doesn't travel with the device, so that means you keep control of the security of the data. You control the writing of the data to the device, and once we get the device back, we're going to verify that it hasn't been tampered with by using established external tamper checks. We're also going to verify that the operating system and everything electronically about the device is secure and hasn't been tampered with. Once that has happened, we're then going to copy all of that data into your S3 bucket. So with AWS Snowball Edge, you have 100 terabytes of capacity, and we have 10, 25, and 40 gigabit network connections. You also have the ability to write to the AWS Snowball Edge via NFS clients, and it also has its own S3-like API. So if you have an application in your data center that supports Amazon S3 API, you can write directly to the AWS Snowball Edge using that. With the traditional AWS Snowball, you have a client that acts as an S3 API, which can copy the data and write data into the AWS Snowball for you. On the far right of the slide, we have the AWS Snowmobile. This is the exabyte scale device. When you order the AWS Snowmobile, we'll drive it to your data center, you plug it in, you fill it up with data, and then we'll drive it back and load all of that data into your S3 environment inside of AWS. So the AWS Snow services are a way that you can move large amounts of data without having to saturate your WAN. Or if you have a location where the WAN quality isn't that great, you could send one of these devices there. One thing to remember is when you're moving large amounts of data and you need to do it quickly, the Snow family is a way for you to do that. Once it gets into AWS Object Storage, there are 4 highly durable storage offerings. The Amazon S3 Standard for general purpose storage of frequently accessed data, Amazon S3 Standard Infrequent Access, or Amazon S3 One Zone Infrequent Access for long-lived but less frequently accessed data, and finally Amazon Glacier for long-term archive. The AWS Object Store offerings provide 11 nines of durability, which means if you store 10 million objects with Amazon S3, you can, on average, expect to incur a loss of a single object once every 10,000 years. One of the trends discussed earlier was auditability and the need for immutable storage. Immutable storage provides protection against ransomware and other attacks that are increasing in existence today. With Amazon Glacier, there is a feature called Vault Lock. Vault Lock allows you to easily deploy and enforce compliance controls on individual Glacier vaults via a lockable policy, Vault Lock policy. Once locked, the Vault Lock policy becomes immutable, and Glacier will enforce the prescribed controls to help achieve your compliance objectives. You can deploy a variety of compliance controls in a Vault Lock policy using the AWS Identity and Access Management policy language. For example, you can easily set up write once, read many, or WORM, or time-based records retention for regulatory archives. We touched on Amazon EBS snapshots earlier when discussing cloud gateways. Snapshots are the same volume types that are also used by our EBS storage. The snapshot capability is a way to back up and protect the data on these volumes. To back up the data or create an authoritative copy of the data within EBS, we create a snapshot of that data, which is a point-in-time copy, and then writes it to S3. The snapshots are incremental and only capture the net new data. The snapshots will keep enough data to enable a full restore of that volume, so even if you delete an earlier snapshot, the relevant data from the snapshot is preserved for other snapshots to be able to create a full restore of that volume. One of the benefits with snapshots is the durability that comes from S3. Plus, as they are space efficient because you're only paying for what you need to use. How? Because the first snapshot is a clone, and then all subsequent ones are incremental. Another capability is the ability to spin up a new instance in another region by creating an EBS volume from a snapshot and attaching it to the EC2 instance. The snapshot capability is accessed through the console, and further information, as with many of our AWS services, is available online via our user documentation. The AWS Storage Gateway family enables you to build hybrid storage solutions when you're connecting infrastructure, applications, and servers inside of your data center to AWS. This enables you to take advantage of the durability and low cost of S3, the low-cost archiving capabilities of Glacier, and the data protection with things like Amazon EBS snapshots for volumes of data that's running inside of your own data center. We break down the AWS Storage Gateway family into 3 modes. So on the left-hand side, you can see that we have ways to support files, volumes, and tapes. And on the right-hand side, you can see that we have targets such as S3, Glacier, and EBS snapshots. An important thing to note about the AWS Storage Gateway family is that all modes support AWS CloudWatch, AWS CloudTrail, AWS IAM for security management, and AWS KMS for encryption. So if you're using AWS today, the same tools that you use to manage and operate your AWS environment can be used with the AWS Storage Gateway. The first thing that we'll talk about is the File Gateway. The File Gateway provides an on-premise file storage solution that's running on a virtual machine inside of your data center. It's exporting NFS version 3 and version 4.1, which means that your Linux and Unix workloads and also some of your Windows workloads can connect. We then have an HTTPS connection back to the Storage Gateway infrastructure in AWS that connects to S3, SIA, as well as Glacier through lifecycle policies. So when you connect the File Gateway virtual machine to an S3 bucket, you can have up to 10 buckets connected to that virtual machine for the File Gateway. So each bucket becomes an NFS mount point that enables you to choose where you write data into and whether it lands on S3, SIA, and also enables you to take advantage of the lifecycle policies. So all the flexibility that you have with an S3 bucket today, you've got with File Gateway, because all the File Gateway is doing is presenting an NFS export or NFS mount point to that S3 bucket. It's important to know that with all of the Storage Gateway modes, it provides you a caching layer, where you can have up to 16 terabytes of cache for the virtual machine, which means that any data that writes to the Storage Gateway is going to be stored locally in cache. This enables you to get a fast response back to the application server, then in parallel, the virtual machine is going to start streaming the data into your service in the AWS environment. So for example, if you were to write word.doc to File Gateway, what you will see in your S3 bucket is an object named word.doc. And if there's a directory structure, say it's users/luke/mydocs/word.doc, we'll take that directory structure and we'll turn that into the prefix for the object when we write it into your bucket. So this means that you can migrate data from your application servers inside of your data center, put that in S3, and then enables you to perform real-time SQL queries using Amazon Athena or process it using Amazon EMR. Next, we're going to talk about the Tape Gateway. Tape Gateway fits into a couple of different use cases, and after I've explained how Tape Gateway works, we'll walk through an end-to-end workflow of how you would back up data using the Tape Gateway. The Tape Gateway presents 10 drives, 1,500 slots, and a robot as part of a virtual tape library. Next, you connect it via iSCSI to your backup software, and is able to go through and index the library, and then you can create tapes as and when they're needed. One thing that's important to know about the Tape Gateway is that when you create tapes, you only pay for capacity that you're using. So if you could create 100 2.5 terabyte tapes, barcode them, but then only write 1 gigabyte of data to those tapes, you would only pay for 1 gigabyte. So as with all AWS services, you're only paying for what you're actually consuming. But you can go ahead and create all of the tapes in advance so that you're ready when your backup application needs them. As I mentioned previously, the Tape Gateway does have local cache. With the Tape Gateway, you could have up to 16 terabytes of cache. And what that means is if you're backing up 10 terabytes of data, that entire backup will fit in cache. If you needed to restore data, you are restoring data out of cache, at least until the next day's backup. All of your data gets stored inside of AWS in the backup component of the Storage Gateway. To view the data stored in AWS, you have to go through the Storage Gateway service, as we do compress and encrypt the data before it traverses the network. So how this works with AWS Storage is for all data that is written to a tape in the drive, the same data is written to S3. So if the tape is still active in the library, that means that inside of the AWS Storage Gateway service, that data is in S3. If you then export a tape out of the library, the data gets life-cycled to Glacier as an archive, similar to how you would do this with your traditional backup software today. So it's the same workflow for writing tapes and managing tapes, but using AWS. As discussed earlier, here is a quick example of a workflow. You have a backup server writing backup data to a disk appliance, and you have a tape library for on-premise archiving. Then you're sending those tapes to off-site into a vault for longer-term archiving. First, you deploy the Tape Gateway virtual machine. You connect to the service and configure the backup server to connect to the Storage Gateway via VTL. Now the backups are being written to Amazon S3 and then archived to Amazon Glacier. you can now stop writing to the tape infrastructure and utilizing the offsite storage. Typically, all of those old tapes are going to expire at some point, so you can stop adding to that stack, stop buying physical tapes, and stop making archive copies or clone copies into your library. Keep your backup disk appliance, and that's probably doing something like deduplication. And over time, your old tape archives are going to start to expire, and as they expire, take them out of your backup software and out of the offsite storage. Over time, you'll be able to completely remove all on-premise storage infrastructure and have all of your backups going into the Tape Gateway virtual machine. So the Tape Gateway provides a mechanism to migrate data out of your old archive into AWS, preserving the workflow you have today. Now for a Tape Gateway case study. Like any modern educational institution, Southern Oregon University generates a lot of data from course materials to administrative documents. Much of its data exists in virtualized on-premise data centers. The university used physical tape backups stored in 2 on-site tape libraries, as well as in a vendor's archiving facility. To keep this information safe in case of disaster, employing Veeam backup software to write data to tape. And as their network service manager stated, using AWS Storage Gateway, they switched from physical to virtual tape backup simply by dropping the gateway's virtual appliance into our existing Veeam workflow. Setting it up took 3 hours at most, and now they had the capability to create virtual tapes as and when they needed at a click of a button. The key point here is that you can deploy Tape Gateway with minimal impact to your current workflow. The next thing we'll talk about is the Volume Gateway. The Volume Gateway storage is presented over iSCSI, where you get an iSCSI LUN just like if you had a SAN storage array. Just like with tape, it's compressed and encrypted and then sent over an encrypted connection. It's stored in Amazon S3, and here you can take snapshots using the Amazon EBS snapshot service. You get up to 16 terabytes of cache inside the Volume Gateway virtual machine, and in this instance we have 2 different modes. The first mode is cached, and with cache mode you get up to 32 times 32 terabyte LUNs, which represents 1 petabyte of addressable storage capacity back inside of the service. You can mount that from any server, any workstation that supports iSCSI, and start working with it. The second mode, stored volume mode, where we keep a copy of all of the data on the LUN inside of the virtual machine. With the stored volume mode, all of the data is going to be stored in that virtual machine. That means that all of your writes and reads are going to happen to and from cache inside of the Storage Gateway virtual machine. And where this becomes interesting from the migration and backup standpoint is that you can use this to back up data from an existing data center to AWS. So you can see on the left we have an application server where we have an existing volume, and this would likely be over a SAN. To use the Storage Gateway and stored volume mode as a backup tool, you would deploy the virtual machine in your data center. Then take that volume, you detach it from your application server, and you attach it to the Storage Gateway virtual machine. Inside of the Storage Gateway virtual machine, we're not going to rewrite any of the data, we won't format it, and we're not going to write a new disk signature. Everything will stay as it was, and your application server is now going to connect to that LUN via iSCSI, and everything will look as it did when it was connected to it natively. But now the Storage Gateway virtual machine is in the data path. Next, we're going to take that data and we're going to start bootstrapping it, which means we're going to start copying it in aggregate blocks up into the Storage Gateway service to create a new volume. Now you can take a snapshot, and when you take that snapshot, this is where you can actually back up the data and load it into AWS. Because once the data is done bootstrapping and we take our snapshot, it is now an authoritative copy of your application. We can now deploy a new EC2 instance, and in this case it's a Windows server. We can take that snapshot, and as it will be an EBS snapshot, which means we can turn it into an EBS volume, we can convert that into a volume and attach it to the EC2 instance. Now you can take away the other infrastructure and have all of your data, and your application server has been migrated with minimal amount of downtime and minimal amount of overhead and efforts to get the data into AWS. And now let's see this in action. In this demo, we have created a volume gateway, in this instance, demo gateway, and we have 1 volume created. If we click through onto that volume, we see it's being created as 50 gig in size and has 0 snapshots. Now, if we log on to our source system, which is a Windows instance, and we check the disk and file management, we'll see that we have 2 volumes mounted, the root, and now we see that 50 gig volume we just mentioned, and that is attached to an Amazon Storage Gateway via iSCSI. That has been mounted as a D drive called demo volume D drive, and in there we have a number of images. Now, these images have been downloaded from the NASA website, and these images are publicly available. Now, if we go back to our Explorer, and let's just double click on the moon image, and we see we have a picture of a moon. Again, note 50 gig in size, it's a demo volume. We're going to our target Windows server now, and again we only see we have a root volume, no other additional volumes, and just a C drive mounted. Now if we go to our console, that same volume, we click on that volume. Now we want to create a snapshot of that volume because it's already been bootstrapped. So we call create EBS snapshot. We're going to give it a name, demo volume, and then we go ahead and create the EBS snapshot. Now once it's been created, we can then click on that snapshot, as you can see, and it takes us into the snapshot. Now from this snapshot we see it's 50 gig in size, it's called demo volume. We now want to create an EBS volume of this snapshot. So we go to Actions, Create Volume. All we're doing here is making sure the volume's being created in the same AZ as the target Windows server. Once we've done that, we check that again, it's 50 gig, and then we go ahead and create the volume. Once the volume's created, again, we can then go and click on that volume. Now the next step, remember, is now we need to attach that volume to our target Windows server. So we see the volume highlighted, we go Actions, Attach Volume. Here we select which instance, the Windows target, and then click Attach. As you can see, it's going ahead and attaching it. Now let's go to our target destination, refresh our files and disks, and now you'll see a 50 gig volume has been mounted via Amazon Elastic Block Store. This is no longer Storage Gateway because it is now an actual volume attached to an EBS instance. Important thing here is now we look at Windows Explorer. It's called Demo Volume, D drive. We've preserved the same disk signature. And clicking on the moon image we looked at before, we see the moon image and the other images have been migrated and backed up to our new Windows server. Let's go back to our source system. Again, it's the same moon image. We haven't changed anything on the source, and it's exactly the same now as the target. So now to finish up, I do want to point out the AWS Partner Network. So today I've mostly talked about AWS solutions for moving data and backing up data on AWS, but we do have a very rich partner network. Our partners can perform services themselves, so you'll see backup and restore. Those are all partners that can provide the services to protect your data in AWS. And then we have partners that specialize in things like migration, even building primary storage systems on top of AWS with business continuity and disaster recovery. So you can look to our partner network to provide not only services but even solutions that we don't provide natively today at AWS. Finally, the last thing we have is storage training that's available. So if you go to aws.training, you'll be able to go in and find courses and deep dive on things like S3, EFS, EBS and Storage Gateway. To gain more confidence and hands-on experience of AWS, you can access the digital and classroom training built and delivered by AWS experts. AWS also has a wide partner ecosystem to help you focus on your success and take full advantage of all the business benefits that AWS has to offer. To learn more about APN partners and find the right one that fits your needs, please visit the AWS APN booth at our showcase. Finally, I'd like to thank you for attending today and sticking it out until the very end of the presentation.